As you may or may not remember, I was working on this Unitra Console, and today it's time to take a look at the radio. And to get the radio out, we need to dive into the console and remove these 6 screws that are here. You can only see 4, but you get the point. There's 2 more to the right. Although the radio now is loose, you can't remove it quite yet. Not only are there a lot of cables in the way, some of them are soldered in. For example, the power and balance connector that you see here, it's soldered in, even though it also has 2 connectors that you will need to remove one of the tubes to get to. That's not the only connections. It also gets its power directly from the transformer, and that's soldered in. So the blue and yellow line you see here, that's the power, and the yellow connects down to the ground on the right side, and the blue is connected to the other side. It's hard to see, but it's there. The power wiring inside the console is a bit messy. The record player is connected via one of these connectors, so you didn't need to desolder that one. But there's more things that are connected, like for example the power socket that is meant for the tape recorder, and below the radio in the storage there is a light bulb. You also need to desolder the speaker transformers, because otherwise you can't remove the radio as it's soldered directly to the speaker transformers. Remember to mark each cable and number them. That was already done on mine for some reason on plasters. And finally, there's a small extension cable for the antennas that you need to remove. And that should be screwed in with 2 little screws, where you again need to get into the compartment underneath the radio to get rid of them. There's actually only 1 screw on mine, but there should be 2. Then you can finally take the radio out. You can after that take the power switch out. I tried to do that first to avoid desoldering it, but that failed, so don't do that. Before I even start looking and cleaning up here, I'll just have to show you this. Look at this switch mechanism. Amazing. And now it's time to take a look at the radio and see what needs fixing. Because the radio crackles even when the volume is off, that means that there are some capacitors somewhere that need changing. But most capacitors in here look like capacitors of this type, which is a type I haven't seen before. It turns out that that's Styroflex, a type of polystyrene capacitor. They're okay and do not need changing. Everybody agrees on that. This capacitor, however, are paper and wax capacitors. They don't look like it, but they are. Usually paper and wax capacitors look like they're covered in wax. These ones look like they're covered in concrete. I don't know if it's a sealant or if the wax have turned into something else, but that one should not be 264 nanofarad, it should be 600. So yeah, this clearly needs changing. Electrolytic capacitors often also go bad. These ones actually measure okay in capacitance, so maybe I didn't need to change them. But 13% V loss, yeah, that's not great. So I decided to change them anyway. This particular capacitor is 2 capacitors in 1. You can't buy those anymore, so I'll have to fix something special for that. That capacitors were actually easily replaceable by simply using 2 capacitors. But the second double capacitor in this radio has a screw connection and is using the case as the negative connection. So that was not easily replaceable with two capacitors. So I took the two capacitors I needed to replace it and hot glued them to this piece of lab board. On the underside I then soldered the negatives together so they formed a little strip of metal that would then connect the chassis when I mounted it in the mounting spot. And I then just strapped it in with a cable tie. That seemed to work. Now these capacitors is another challenge. They have 3 legs, and that's not because they're double capacitors as the others. No, these ones are shielded. I've never seen a shielded capacitor before, and I can't find one. So I'll have to make my own. So the solution I came up with, which may not be the best one, is to try to shield existing capacitors with copper foil. So to avoid getting the copper foil touching the legs, I first put heat shrink around the capacitors so that it's a little bit around the legs. Then I strip out this self-adhesive copper foil and put that around the capacitor. I then soldered the third leg on to the copper foil, and lastly put more heat shrink around everything so that the copper foil wouldn't short circuit on anything. However, when I desoldered the capacitors, I noticed that there was some bad corrosion on the board. In fact, so bad that some of the traces had lifted from the board. The culprit turned out to be some electrolytic capacitor on the other side of this board leaking. But that means that I need to stabilize these traces. I need to get them attached to the board again before I solder. And I was not quite sure how to do that. There is high temperature epoxy that can be used for this, but that's extremely expensive. We're talking about something like $50 for just a few milliliters. So I instead tried just normal high temperature epoxy, not made specifically for repairing circuit boards. I also tried this conductive glue as well as normal super glue. And as well as standing the high heat, it also needs to attach to the circuit board properly. There's no point of a high temperature glue if it doesn't actually glue to things. So first I tried with super glue as a baseline, and then I painted some of the conductive glue on, and lastly I put on a blob of the epoxy. And I let all that cure overnight. The conductive glue did conduct electricity if you get a good connection with it, which was hard to do. The super glue and the epoxy did not conduct electricity. However, more importantly, the conductive glue did not really glue very well to the surface. It scrapes off very easily. The epoxy, unfortunately, also did not attach. It lifted right off. Now the super glue is not very hard, so I can destroy it by scraping at it, which is what I'm doing here. But as you see, it doesn't lift off. It actually attaches to the surface. So on this particular circuit board, only super glue worked as a glue. It's not very temperature resistant, but as you can see, it doesn't start smoking or burning or anything. It does melt if you hold the soldering iron there for a while, but if you solder reasonably quickly, it's fine. So super glue was the choice. Now to reach this properly, when I did the gluing, I needed to remove the circuit board, which I didn't originally intend to do. It has grounding wires that are soldered into the frame, and to desolder that you need a high power soldering iron. So thanks to Uncle Henrik for lending me his, and he also gave me the copper foil, so thanks again for that. And after a lot of desoldering, it's not just these 4 grounding wires to the frame, there's also a lot of other cables going in and out from this circuit board to the rest of the radio. And then a lot of cleaning because there was dirt and wax from the paper wax capacitors and things like that. We can now look at the damage. And only one pad has lifted completely and there are no broken traces or anything like that. So it's not too bad. A little bit of super glue will fix this. So I dropped on some super glue, made sure it got in under the pad properly. And then I clamped it down with a clamp. I had already checked that super glue did not attach to the plastic that this clamp is made of. So that worked very well. After that was fixed, I only needed to replace all the capacitors. However, I noticed that these 2 capacitors in the middle here weren't actually Styroflex, or maybe they are, but they look different. And they also look different from the paper and wax capacitors. I was not able to figure out what it actually was. To add confusion, they have a different set of values than what the circuit diagram says they should have. Very confusing. In the end, I decided to replace them with modern capacitors of the same value as the capacitors said on the outside and not what was on the circuit diagram. Putting this thing back where it belonged was easier said than done, because there are a couple of screws, especially this one here, that were really tricky to get in. I have to put my hand in under the radio and through the radio to be able to reach to put the screw into the screw hole. Serviceability is not the main concern of this design, that's for sure. And of course the big soldering iron has to come out again to solder in the groundings to the chassis. That's the capacitors done, but there are several things left to do, like fixing the switches, fixing the light bulbs, which were trickier than what I expected, etc. And this video is actually almost 13 minutes long already, so you'll get bored to death. So I think I'll quit it there. See you next time. Really hope it won't take another year. Whew.